Hey everyone! So this unit we are going to talk about how our body metabolizes caffeine and alcohol. I want to be very clear, we are not here to tell you what you should and should not be doing. We are here just to talk about what our body is doing and talk about how our body is metabolizing both caffeine and alcohol. So to start with, I always like to build off of previous knowledge. So this right here is one of our functions that we saw in the finance section. So we saw the PERT, that is when we are compounding continuously. And we have this function of 8,319.59 equals 3,000 e raised to the 0.068 raised to the 15. So this is a very typical type of problem we saw back in the finance section. I want you to take 20 seconds, pause the video, and think about what did each of those three numbers represent. Okay, so you should have identified that 3,000 represents our principal. The 8,319 represented our accumulated balance, and the 15 represented our time. Okay, and then this right here represented our rate. So in this case, it would have been 6.8% as our rate, our APR. Well, what we're going to do is we're going to change up that language just a little bit. So we're going to be looking at a Tylenol example first and really explore this exponential function. So instead of calling it the principal, we're now going to be referring to that same spot as the initial value. And in general, this right here is our exponential function, and A represents our initial value. Okay. Next, we have our inputs and output. So time is typically our input, and then our output, so that's our T over here, and then our Y is going to represent our output. So instead of accumulated balance, we're now going to represent it as the output, or sometimes referred to as the end value. Okay, something that is new, when we first talked about this compounded continuously formula, we were just using this E raised to the R power or to the rate. We're going to change that up just a little bit, and now this is going to be referred to as the factor. And so two things about our factor. So notice that we're going to be using the letter B for it. If we come over here to our exponential function, here is our B position. So when our B is greater than 1, it is known as a growth factor. And when our B is less than 1, it is known as a decay factor. Okay, and notice that I want to compare these two formulas. I want to compare the continuously compounding formula to this generic exponential function. So Y and A represent the same ideas. So before we called it accumulated balance, now it's referred to as the output or the end value. Next, the 3,000 represents our principal. We're now going to be using the letter A to represent that same thing. So principal or initial value. Here, the E raised to the R power, when it was continuous, that was our continuously compounding raised to the rate. We're now just going to simplify that to represent our B value, which is the factor. Okay, and then you'll notice that both formulas are raised to the T power, which represents time. All right, I want to explore the exponential function a little bit more before we get into our caffeine problem. So I still have the exponential function shown on the screen here. And what we're going to do is show how those values show up on our graph. So our input is our time, and that is always going to be our power. That shows up as the x-axis on our graph. So that's time t in hours. And then our output, y, is still going to be the amount of Tylenol in milligrams in your system. And so that's going to be our output. Okay, so when we are looking at this exponential function, we've got all of this detail that is showing up on the graph. So for example, we have 2,433.2. The 2 is still going to represent our input, and it's because it's in the x position on a point. The 433 is going to represent the output, which is going to be the y value. So part A, it says, based on the information given, what does the point 2, 433.2 mean in the context of our problems? So the 2 represents the input, which is our time in hours, and the output is the amount of Tylenol, which is 433.2 milligrams. And so we can write that as a sentence. So 2 hours after taking the medicine, the person will have 433.2 milligrams of Tylenol in their system. So that's how we represent a point, is that an input, output. So we use a point to represent data in our graph. So the 2 is always going to be the input, and you can see on our x-axis that represents time. The output represents the amount of Tylenol. So that's the second part of the point. Okay, so the next question, what does the T represent? So we've mentioned that a few times. So T represents our time in hours since taking the medicine. And anytime we are using a function, both the input and the output will always be stated in the paragraph. So if you read the paragraph in your worksheet, it says, let T represent the number of hours since taking the medicine. This next part of that sentence says, Y is going to represent the amount of Tylenol in milligrams in your system. Those two things will always be stated whenever we're given a function. And then that answers our second part here. So the Y represents the amount of Tylenol in milligrams in our system. All right, so now we're on to part D, and says, what is the initial amount of acetaminophen taken? Well, we talked about our exponential function up here, and you'll notice now at the bottom of the screen, I have this function written. And so remember earlier we talked about the A represents the initial value. So when we come down to this example, this 750, it is in the position of the initial value, which then means that there are 750 milligrams of acetaminophen or Tylenol taken. Right, and again, we know that because of where it is located, comparing the exponential function and the equation that is given. Next, for part E, it says, does the 0.76 represent a growth or a decay factor? So we want to compare if this is greater than or less than 1. So just a quick little reminder, if B is greater than 1, it's a growth. And if B is between 0 and 1, it is a decay. And so the fact that 0.76 is less than 1, we know that it's going to be a decay. Okay, and then again, connecting it to our equations, our B always represents our factor, and that 0.76 came from this equation right here, so it's 0.76. Also, we can see that graphically, as we read our graph left to right, you can see this blue graph as we're going left to right is going in a downward direction. So whenever it's going in a downward direction, that always represents a decay. And then for our growth factor, just to let you know, graphically, if we had a growth factor, it would be going in an upward direction. And the B value would be greater than 1. I'll put those B values on here real quick. All right, next question. It says, how much acetaminophen is in your body after 2 hours? So we can actually answer this question in 2 different ways. So it's asking us for 2 hours. If we go over to our graph, you can see that we have an input of 2, which represents 2 hours. So then we know how many milligrams of Tylenol are in our system. So we could say after 2 hours, there is 433.2 milligrams of, and I don't mind if you say acetaminophen or if you want to just say Tylenol, that is fine in the system. One's just a name brand. Acetaminophen is the generic name for that same medicine. So I also mentioned that there was a second way that we could answer question G. So we know our time frame is going to be 2 hours. We can also use our equation to help answer that question. So we could take our Y equals 750 times 0.76 raised to the T, which again is time, and we know our time is going to be 2 hours in this example. So I could plug in 2 into the equation, and then we can solve this using our calculator. So to raise it to that power, you've probably seen the little caret symbol. So you would write it in like this into your calculator, and your calculator will automatically put it in that power of 2. And your calculator will give us that same answer of 433.2. All right, part H. It is saying how much acetaminophen is in your body after 4 hours. Well, if we look at the graph, we do not have 4 hours as one of our data points, so that means we have to go to our equation. So we're going to do y equals 750 times 0.76, and this time we're going to raise it to the 4th power because we are 4 hours in. And then you are going to plug that into your calculator, and you should get 250.22 milligrams. Again, as you plug it into the calculator, make sure you do 750, parenthesis, 0.76, parenthesis, caret 4. And that's how you can plug it in. All right, and then those first 2 problems, we stuck to whole numbers for hours, but we can choose any time frame. So what if we wanted to know 4.5 hours? We could then take this as our t-value and plug it into our equation just like we did on the previous 2 problems. So we get y equals 750 times 0.76 raised to the 4.5 power. Once you plug that into your calculator, you will get 218.13 milligrams. All right, so the previous examples all gave us an input of time, so we knew that we wanted 2 hours, 4 hours, 4.5 hours, and then we solved for the amount of Tylenol in the system. But what if we change it up, and this time we want to know the time, and we know the amount of Tylenol in our system. So that's what we're solving for here. So it says how many hours, so that means that we are solving for time. And then we want to know when the person will have 190 milligrams of acetaminophen or Tylenol in their system. This actually should say 190.2. Okay, so there are 2 ways that we can think about this particular problem. So the first way is to look at our graph. So when we look at our graph, you can see that we have an output of 190.2, and we can see that our input is 5 hours. So our first way is to look at the graph, and we see the input is 5. Okay, alternatively, we can think about plugging it into our equation right here. So our y represents our n value. This is our amount of ibuprofen in our system. We know that's going to be 190.2 equals 750 times 0.76 raised to the t power. So notice that we are solving for t. Okay, so one of the things about this type of equation, when we have the variable and the exponent, is that when we go to solve this, we have to use some algebraic skills. Typically, how we solve this is we use logs, and that is reserved for the college algebra courses. This population of students who are taking Math 120 typically do not need to know how to use logs outside of a math classroom. So what we're going to be doing in just a little bit is using technology to help us answer this question. So at this moment, we're just going to be using our graph, and we see that we have an input of 5. So that means a person will have 190.2 milligrams of Tylenol in their system after 5 hours. Okay, when we look at the next problem here, we have 110 milligrams of ibuprofen in the system, and again, we want to know how many hours. So how long will that take? So our equation setup would be 110 equals 750 times 0.76 raised to the t power. If we look over at our graph, we do not have an output of 110. So that means we need to find a different way to solve this. We're going to let technology help us answer this question. All right, so we're going to start off our Excel spreadsheet, or any kind of spreadsheet. You can be using Google Sheets. And we're going to, in the very first column, write time, which is represented by T, and then we can put in parentheses, that stands for the input. In the B column, we're then going to type in the amount of Tylenol, which is our Y value. And if you want to put in parentheses, that is our output. Okay, you can see that the writing is starting to overlap each other, so we can make that cell slightly bigger. To do that, you're going to move your cursor to that little line between the 1 and the 2. We're going to hold and then scroll down, and that makes the cell bigger. Also, I can highlight those two spots and then do wrap text, which is this button right here. So we've got this little button right here where we can wrap the text, and then it formats it so you can read what's in each of those cells. All right, so now what we're going to do is type in our numbers. So if this particular one, it's short enough, you can just write 0, 1, 2, 3, 4, 5, 6. But if you wanted to use our formulas that we saw in previous lessons, we can do a formula where we do equals, click the previous cell, and then do +1, and then hit enter. So what that does is it takes the previous cell and adds 1 to it. And then we can scroll our formula down. So again, we've seen this in previous lessons where we're going to move that cursor to where it's over that little box in the right-hand corner. So hold and scroll it down. And so every single cell is taking the previous cell and adding 1. All right, now for our formula, that's going to look like what we saw on the previous page. So equals 750, parenthesis, 0.76, close the parenthesis, and then we're going to do the caret. And then here we want it to represent the power to represent our time frame. And our time frame is always going to be what's in this input over here. So instead of raising it to the T or typing in a number, we're going to click cell A2 to represent the time of 0. And then I'm going to hit enter. Oh, this happens a lot. This is probably happening on your screen as well. What it needs is a little asterisk in between the 750 and the parenthesis. It'll probably autocorrect it, but if you need to, you can also enter it yourself. So this little asterisk right here needs to be in the formula. All right, so then once we've got that, we're going to go ahead and scroll that formula down, and you can see that the numbers are changing. So if I click, for example, this cell B4, it's telling us that after 2 hours, there are 433.2 milligrams. That matches what we saw on the previous problem. And you can see here in the formula that it is now using cell A4 for our time frame. So initially we put in A2, and then every single time we go down, it changes. It's using the cell to the left to represent the time. And if we go down to the 5-hour mark, which was another problem that we saw earlier, that gives us that after 5 hours, there's 190.16 or 0.2 milligrams in our system. Okay, next what we want to do is graph this function. So the way that we can graph it is we're going to highlight these 2 columns right here, and we are going to go to Insert, and then you should see this little section that says Charts. We're going to click on this one that is called a scatter plot. There's lots of little dots there. We're going to click on it, and I'm going to choose the one that connects. So we're going to choose the second one with smooth lines and markers. Okay, so when I click on it, we get this right here for our function. Okay, I want to highlight some key things that are showing up. This point right here, when I click on it, you can see that it is showing up on the screen as parentheses 0, 750 parenthesis. That represents that the input of time is 0. The output is 750 milligrams. So that represents our initial value. Okay, so if we go to question M on our worksheet, it says, how is the initial value represented on the graph? It is showing up as this y-intercept. Okay, other things to note on the graph is notice that it's going in a downward direction, which makes sense because it is a decay. If I go back to the function, our 0.76, that was less than 1. So we knew we had a decay factor, which is why our graph is going in a downward direction. Our next question says, is a time frame from 0 to 6 a good set of values? Well, you can see that after 6 hours, that there's still 144 milligrams in our system. And so there's still a lot of medicine to be metabolized, so we can increase both of our time and the amount of Tylenol. So I'm going to do each of those separately. I'm going to scroll the 7 down, and I'm also going to take the function and scroll that down as well. And you can go down as far as you want. If you want to go even longer than what I've shown on the screen, feel free to do that. Play around with those numbers. Okay, and so then for part O, what I want you to do is it says, if we add more values to the input, explore this in your table. So I want you to pause the video and answer part O, and then we'll come back together. So go ahead and pause. All right, so here we've got our table. I'm going to go ahead and actually scroll it down just a little bit more, and I'm going to redo the graph. I forgot to show that to you before I told you to pause, but we can do that here. So we've got these 2 columns. I'm going to go ahead and do insert. And then here is our new graph. So this is taking it out much further. Earlier we had stopped around the 7-hour mark, and you can see as time goes on, that amount of Tylenol in our system is getting closer and closer to 0.